Good morning guys and welcome to My Dear Math. Today is our second class of the chapter 1 of grade 10. Now in the previous class we already talked about HCF and LCM and three ways of finding out the HCF and LCM of a given set of numbers: prime factorization, common division, and by listing out the factors or the multiples. In this particular class we will be doing a few sums pertaining to the concept that we studied in the previous class. In the previous class we also talked about the difference between prime factors and normal factors. We learned about the fundamental theorem of arithmetic. So let us see the sums which will come in the examination or which you need to study based on the concept we have already discussed. If you have any doubts regarding the contents of this particular video, please mail me in the mail ID given below in the description box. Let us start with a very few basic questions. Okay, which is the smallest prime number? The smallest prime number is 2 because 0 and 1 are not considered to be prime numbers. Which is the smallest odd prime number? 2 is an even prime number. So next number, which is 3. It is the smallest odd prime number. So which are the even primes? So they have not asked you which is the only even prime. Which are the even primes? You know that there is only one even number, that is a prime number. So it is 2. So there is only one number which is 2. Okay. Now, which is the smallest composite number? Now, you know that 2 is a prime number, 3 is a prime number, 4. 4 has got factors of 1, 4 and 2. Therefore, the smallest composite number is 4. Okay. Smallest 2-digit composite number, obviously it is 10. What are coprimes? Coprimes are those numbers which do not have any other common factor other than 1. Such numbers are called coprime numbers. So, in the case of coprime numbers, their highest common factor will be 1. Okay. Now, examples of coprime numbers: 2 as well as 3, 3 and 5, 2, 3 and 5. All those are coprime numbers because they do not have any other common factor other than 1. Okay. I hope these are all very basic questions. You must already be very clear about these things. So, now let us move on to the sums. 6 bells tolls at intervals of 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds and 12 seconds. Okay. In 30 minutes, how many times do they toll together? Toll basically mean ring. So, how many times all the 6 bells will ring together? That is what we need to find. In order to understand this particular sum, you need to understand what exactly are they trying to ask us to find. Now, in this question, there are 6 bells. To make the concept clear, let me reduce the number of bells to 2 bells. Okay, I forget about this question completely. I am taking randomly 2 bells that will toll at intervals of, the first bell will toll after every 2 seconds, the second bell will toll after every 3 seconds. I am going to start with a random time. Let us choose 10 a.m. Okay, the first bell has tolled at after 2 seconds. Okay, this represents minute and this represents second. Okay, now what about the second bell? The second bell will toll at 10:03. I'm talking about number of seconds. Now after 2 more seconds, the first bell will toll again. The second bell, because it is tolling after every 3 seconds, it will toll at 6 seconds. Now, the first bell will toll at this. The second bell, it will toll at 9. It will go on and on till somebody decides to stop the bell. Now, what can you see from this? The first ring happens here, the second ring happens at 3 seconds. The third ring happens here, fourth ring over here, and so on and so forth. But you can see that after 6 seconds or at the 6th second, the tolling happens for both the bells. Even the first bell as well as the second bell tolls at 10:06. Okay. Now, let us write the remaining part. So on. What can you see again? Again after 6 seconds, both the bells are tolling simultaneously. See, 12 seconds. So 6 seconds is the minimum time after which both the bells will repeat their tolling simultaneously. So what is this 6? 6 is basically a number that is common to even the first bell as well as the second bell, which is, so basically this 6 second is a multiple of 2 second as well as 3 second. That is the reason it is common. Or we can say that 6 second is the least time after which both the bells will toll simultaneously. So basically it is a LCM of 2 second and 3 second. So after every LCM, the bell will start tolling simultaneously. So without even writing this, can you tell which is the next time at which both these bells will toll simultaneously? After 6 seconds, which is 18. Okay. So even if we increase the number of bells, what will change? Only the number of bells will change, but the basic concept remains the same. The bells will toll together after a time which is equivalent to the LCM of their individual times. So now I hope you are clear with the concept behind this sum. Whether to find the HCF or the LCM is basically the common confusion for the students. In this particular sum, I hope you have understood why we are taking the LCM of the numbers. Okay, so now let us get back to the sum. So here I have found out the LCM of 2, 4, 6, 8, 10 and 12, which is the individual times given over here for the 6 bells by using prime factorization. I have used prime factorization, the reason being because that is the method you are expected to use in your examination for this particular class. Okay, not long division, not listing out the factors or multiples, you have to use prime factorization. And so I have broken down each term into its prime factors. 2 is common to all of the terms, so I have taken 2 with the highest power because we are finding out the LCM. 3 is there only for 2 terms, I have taken it, and 5 for 1 term. So I will get 120 seconds as the LCM of these numbers. So after every 120 seconds, all these 6 bells will toll simultaneously. So they are asking how many times in 30 minutes will this happen? Because this time is given in minutes. You can either convert this into seconds or this into minutes. I am going to convert 120 seconds into minutes. So 120 seconds is 2 minutes. So every 2 minutes the bells will toll simultaneously. So in 30 minutes how many times it will toll? In 30 minutes it will toll 30 by 2, 15 times. Okay, that is basic. Now one thing you need to take care in this particular sum is, you know that the bells will toll 15 times. Now the 6 bells, let us assume they are starting at 3, the second bell will go at 4, third bell will go at after 6 seconds, then the fourth bell at 8 seconds, 10 seconds and 12 seconds, and within that interval they will keep on tolling, and after 12 seconds, after 120 seconds, which was our LCM, they will toll simultaneously. Now when the bell started tolling, they are all tolling at different times. So the number of times the bells will toll is the total time divided by 2 minutes, which is 15 times. Suppose all the bells tolled simultaneously in the beginning itself. So all the bells tolled first simultaneously at 10 or any random time at the beginning itself. All the bells rang once. Then it followed the pattern. The first bell rang after 3 seconds or 2 seconds. The second bell after 4 seconds, 6 seconds, etc. so on and so forth. In that case, in addition to this 15 times, you also need to take the time at which it rang first. So that will become 15 plus 1, which is 16 times. Okay. So that is one thing that you need to be very clear. When we are taking the LCM and dividing the total time by the LCM, we are assuming that the initial tolling of the bell happened at different times. If the initial tolling also happened simultaneously, you have to add that also. So it will become 15 plus the initial one, which is 16 times. Okay, I hope I have made myself very clear. Read the sum properly before you start attempting the sum. Traffic lights at a signal change every 48 seconds, 72 seconds and 108 seconds. If they change simultaneously at 8:20 hours, when will they change again simultaneously? Now it is similar to the previous sum, so I am not going into the explanation of why we have to take the LCM of the numbers because I have already done that. So we need to find the LCM of 48, 72 and 108. So let us use prime factorization for finding out the LCM. So you can see that I have found out the prime factors of each of these numbers. I have done the working also here. So whenever you are writing for the board examination, please do the working also because that part also carries mark. So I have broken it down into prime factors, and I have found out the LCM as 432 seconds. Now look at the sum. This is the first time at which the signals changed simultaneously. Now it's 8 hours and 20 minutes. Okay, I need to convert this 432 seconds into minutes. Now in order to convert seconds into minutes, I need to divide by a 60. So I have done the working here, but I don't think it is clear for you people. So let me do it here. 432 by 67. So I will get 7 and 12 by 60, which is basically 7 minutes and 12 by 60 minutes. Now 12 by 60, it is a fraction. I need to convert it into seconds. So it is 7 minutes and 12 by 60 minutes. 12 by 60 minutes, if I am converting it into seconds, I will get 12 seconds. So what I am getting is 7 minutes and 12 seconds. This is the LCM of these three numbers. Basically means after this particular time of 7 minutes and 12 seconds, the signals will change again simultaneously. So it is 8:20 beginning. So after 7 minutes, 27 minutes and 12 seconds, the signals will change again. Find the maximum number of students among whom 1001 pens and 91 pencils can be distributed so that each student gets the same number of pens as well as pencils. So there are 1001 pens and 91 pencils. Now this has to be distributed among a class of students. So there are many students in this particular class. So we have to divide it in such a way that each student gets an equal number of pens as well as pencils. Now HCF or LCM is our main consideration. Suppose we are taking the LCM. LCM will be a number greater than these two numbers, or at least equal to one of the greater numbers. So that many number of students, if you are going to distribute the pens or pencils, you know that at least pencils will go short of. So obviously we shouldn't be finding the LCM. We have to find the HCF. So whenever you are having a doubt in a particular sum whether you should be finding the HCF or the LCM, try to eliminate one of them if you are not able to recognize which one to find. Okay, so now in this particular sum we need to find the HCF of 1001 and 91. So let us see what we are getting. We will do prime factorization obviously. So here you can see that I have done the prime factorization of 1001 and 91 for finding the HCF. So HCF is 7 is common and 13 is common. So I am getting 91. So 91 students have to be there in the classroom. The maximum number of students is 91, so that each one of them receives equal number of pens as well as pencils. Okay. Find the least number of square tiles by which a room 16.58 meters by 8.32 meters can be completely covered. In this particular question, a room or the dimensions of a room is given to you. It has a length and it has a breadth, and we are planning to cover the floor of the room with tiles. We need to find the number of tiles. We do not know the dimension of the tiles. That also we need to find. Suppose you have a room 4 meter by 5 meter, and you have a, let us say 40 meters by 50 meters. It's a huge room, whatever. You have 2 meter tiles. How many tiles do you require for covering this room? What do? We find the area of the room and we divide it by the area of the tile. Correct. Now in this case, the dimension of the tile is unknown to us. So in order to find the number of tiles, our first task will be to find the dimension of the tile. Thankfully, the tiles are supposed to be square tiles. So the length and the breadth will be the same. Now, how do we find the dimension of the tile required to cover a room? So you know that since the length and breadth is given to you, it cannot be the LCM. The reason being the tile cannot be bigger than the room. Okay, either the length or the breadth, it cannot be bigger. So we have to find the HCF. So in order to find the HCF of 16.58 meters and 8.32 meters, we convert it into a very convenient form, which is making it into centimeters. So here I have found out the HCF of 832 and 1658. See, when I am dividing 1658 by 2, I am getting 829, and unfortunately it is a big number, but then again it is a prime number, so I had to check by dividing with 13, 17 and etc. Finally, I came to the conclusion that it's a prime number. So 829 and 832 is 2 raised to 6 into 13. So the HCF will obviously only be 2. Now I know the dimension of the tile. The dimension of the tile is 2 by 2 because it is mentioned it is a square tile. So what is the area of the tile? 2 into 2, 4. So 4 centimeters square. Now what is the area of the room in centimeters square? This number into this number. So here. So finally, when you are calculating this, you will get the number of tiles that is required to cover the room completely. Leo is printing yellow and red forms. He notices that 3 yellow forms fit on a page and 5 red forms fit on a page. If Leo wants to print the exact same number of yellow and red forms, what is the minimum number of each forms that he could print? It's very easy. Now that I have explained a few sums, you should find this exceptionally easy. In this particular page, you have got 3 yellow forms. In this particular page, which is of the same kind, you have got 5 red forms. He wants to print exactly the same number of yellow forms and exactly the same number of red forms. So what is the minimum number that he should print? So obviously, it has to be a multiple of yellow form as well as the red form, which is the LCM of 3 as well as 5, which is 15. I have taken 3 random numbers, 3.08, 5.6 and 7. We need to find the LCM of this. Now, before we start with the LCM of any number system, one thing you need to make sure is that we bring all the number system in a common platform, which means that in this case, the number of decimal points in each of the numbers has to be the same. So, my 3.08 is the maximum one with a 2 decimal points. So 5.6, 1 decimal point, I add a 0 because it is not going to make any difference to the number. In the case of 7, it is this. Okay. Now, I remove the decimal point so that I get 3 numbers, 308, 560 and 700. I am going to find the LCM by using prime factorization. I have done the prime factorization of 308, 560 and 700. So out of these factors, 2 was a common factor. I have taken the largest power. You can see that 7 is a common factor. There is only 1 power, so 7. 5 is present in 2 numbers, so the largest power I have taken, and 11 also. So this is what I am getting finally as the LCM. Now since the original numbers had decimal points of 2 places, I will put a decimal point over here. So my LCM would be 308. In a similar way, we can find the HCF also. So for find the HCF of these 3 numbers and put a decimal place accordingly. So let us find out what the HCF of these numbers would be. So here, as you can see, the HCF would be 2 is common, so I have taken the least power. 7 is common, there is only 1 power, so the HCF would be 28. So 28 is LCM of 308, 560 and 700. But our question is to find the HCF of 3.08, 5.6 and 7. So to convert it into the appropriate form of 2 decimal places, our HCF would change from 28 to 0.28. That is basically to account for the 2 decimal places in the original question. Let us have a look at this particular question. It is slightly tougher than the questions we have done so far. A watch ticks 95 times in 90 seconds. Another watch ticks 315 times in 323 seconds. If both the watches are started together, how many times will they tick together in 1 hour? Now we have done similar kind of sums before. It is basically the traffic signal 1 or the 6 bell chimes or ticks, tolls after 2 seconds, 4 seconds, 6 seconds, etc. And then we were asked to find when they will toll together or when the signal will change after how many times the signal will change after so and so. So what we did was that we found the LCM of the times because we knew that the signals would change after a common multiple of the times that were given to us. But in this case, let us see what exactly is the difference though the sum follows more or less the same concept. Suppose these clocks started together at 10 a.m. So what exactly is happening over here? It is ticking 95 times in 90 seconds. The second watch is ticking 315 times in 323 seconds. What about the previous sum? In the previous sum, the first bell was tolling after every 2 seconds. Okay, for one toll, it took exactly 2 seconds. The second bell took exactly 4 seconds. The third bell took 6 seconds, so on and so forth. Here, for the individual watches, they have not given the time that is required for one tick. They have given you 95 times in 90 seconds and 315 times in 323 seconds. So it is left to us to find out what is the time taken by each watch in order to make one tick. Okay, so how do we find it? 95 times in 90 seconds. So for ticking one time, how many seconds does it need? It needs 90 by 95. Okay. Similarly, 315 times in 323 seconds. So for ticking one time, it takes 323 by 315. So basically, you have two watches now here. One watch ticking after every 90 by 95 seconds and the second watch ticking after every 323 by 315 seconds. Clear? Now what do we need to do? We know that we need to find the time when they will tick together. So for that, we need to find the LCM of this number as well as this number. Okay? We have two numbers which are fractions. So we know how to find the LCM and HCF of normal numbers, natural numbers. Decimals also we learned just now. Now we need to know how to find the LCM and HCF of fractions. So we use a standard formula. LCM of fractions, any two fractions, is given by LCM of the numerators by HCF of the denominators. HCF of any two fractions is given by the ulta of it, which is HCF of numerators by LCM of denominators. Okay, what we need to find goes on the numerator. If it is LCM, LCM of numerators by HCF of denominators. If you are trying to find the HCF, it is HCF of numerators by LCM of denominators. So let us see what we are getting as the LCM of these two numbers. So LCM of these two numbers is LCM of the numerators by HCF of the denominators. I did prime factorization and finally this is what I am getting. I have cancelled 15 and 45 and this is what I am getting. So after this many seconds, each watch will tick simultaneously. Okay. Now what do we need to find? We need to find how many times it will tick together in 1 hour. So we need to divide the time of 1 hour by this LCM. So what is 1 hour? 1 hour is 3600 seconds. Okay. This divided by this particular number. So we will get the number of times this particular, both the watches are ticking simultaneously. So let us see what we are getting as an answer for this. So as you can see, when I am dividing, this is what I am getting, which means that it will tick 100 times simultaneously, plus this cannot be considered as a proper tick. So we will exclude that part. So it will tick 100 times in 1 hour. But we know that in the sum they have given, they started ticking simultaneously. So I have already explained to you the difference between the number of counts when there is a tick that happens in the beginning itself. So counting that, it is 101 times. I hope you are clear with this sum. The only problem with this particular sum was that the time was given in fractions. We needed to find the LCM and HCF of fractions. I gave you the formula for that. Now the second or the main problem was that initially the time was given in a very weird way. Instead of telling each tick happens after 2 seconds or 4 seconds, what they had told was that the first clock will go 95 times in 90 seconds and the second one will go 315 times in 320 seconds. So we had to calculate the time that was required for one tick for each clock. That is the reason mainly we ended up with fractions for times. So I hope you are clear with this particular sum.